Good morning. I would like to go through this practice for doing geometric constructions. This is the review for the Unit 1 quiz. So I'm just going to come in here like I'm a student and show you how to do it. Now, if you need this video, then definitely watch it. But I would strongly suggest that you try this on your own, see what you remember, and then come back to the video for only as much help as you need. Then watch the video in its entirety and make sure that you did everything correct, because you don't want to mistakenly think that just because you did something that it was the right something. Please check your work and see that you did it correctly. So we're going to start with slide 1, which is use this line to create an equilateral triangle. So an equilateral triangle is created with circles. We're going to click from A to B and then back from B to A. These two circles have the exact same radius, length AB, which means all points on the circumference will be the exact same length as AB. That's what you need for an equilateral triangle. So I'm going to come in here with a segment and click one of these intersections where the two circles meet, and notice that I have just drawn in another radius for circle B. And then when I click A and come over here to this intersection point, I have drawn another radius that is on circle A. So all of these lines are exactly the same length, and there's my equilateral triangle. The next one is create a hexagon by making 6 equilateral triangles that share a vertex. Use the given line segment as one side. So we're going to go ahead and click on the segment, or with the circle tool, and do what we just did from C to A, and then from A to C for our first two circles. And I'll go ahead and add the segment in and get my first equilateral triangle in there. So the vertex that I want all of my equilateral triangles to share is C. I'm going to go for C. So I need another circle that needs to go from this point right here over to C. It needed to have the exact same radius as CA. And now I can add in my segments, and I will now have, click, click. I now have 2 equilateral triangles with the same side as the radius of CA. Come in here with another circle, click on that new intersection point and come back to C. I want it to have this exact same radius as all the other circles. Coming in with my segment on that intersection, coming over here to this intersection, and then back to C. And I have a third equilateral triangle. Another circle, same intersection point, back to C. Notice I always go back to C to measure that length for the radius of my new circle. Come in with my segments, intersection to intersection, and then from C to the intersection, and I have my fourth equilateral triangle. Circle, click on that intersection, and then to this intersection to finish this off. Come in here with my segments, intersection to intersection, and then C to that same intersection. Now it's not quite finished off. I do need to do one more segment, and that is from the intersection to my original A. And now I have all 6 equilateral triangles that you can see are inscribed into this circle, and they all share the same radius. I guess it wants me to click again. All right, so let me just show you with the polygon tool where those equilateral triangles are. I don't know if this is really working enough for you to see it. I'll go ahead and finish it anyway. Okay, and there's the second one. Click, 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 click. For the polygon tool, you don't need to do this step. I just wanted to show the 6 equilateral triangles for you very clearly. And then the last one is right there. That was actually our first one. All right, there you go. And let's move on to slide 3. construct an equilateral triangle. So let's go ahead and give ourselves a segment. Well, let's go a different direction. There. Ooh, get all crazy. All right, I'm going to go ahead and label those endpoints just so I can refer to them. Label A and label B. If you want to use different letters, no problem. Grab the circle tool, A to B and B to A, and add some segments. From A to this intersection is another radius of the same circle. These two circles share the same radius AB, so B up to this intersection point. I'll go ahead and label it. Labeled C. So AC is equal to AB because they're radii of the same circle. BC is congruent to AB because they're radii of circle B, meaning that all three lines are the same length. So we have another equilateral triangle. Moving on to slide 4. Find a point that is the equidistant from A, that is equidistant from A and B, and is the same distance from each as they are from each other. So in other words, guess what? Another equilateral triangle. That's right. So I don't need the segment. I can just come in here with the circle and click from A to B and then B back to A. And either of those 2 points will be equal distance from A as it is from B. And so let me go ahead and put that point in there. How about we pick this one down here? Let's go ahead and label it. So point C is the same distance from A as it is from B, equidistant from each. And it is the exact same distance as A is from B. So again, points on an equilateral triangle, but I didn't draw the triangle this time. Moving on to slide 5. Construct an equilateral triangle that is inscribed on the circle. The points all touch the circle. So we have to do the exact same thing that we did in the beginning. So we're going to have to go through this point back to the circle center, and then from this point, this intersection, back to the circle center, and from this point back to the circle center, and from this point back to the circle center. And I need all 6 points to find my equilateral triangle. Do I have 6 points? 1, 2, 3, 4, 5, 6. They are all equal distance from each other, and they are the same distance from the center, because basically what I've done is created all the points to create all those equilateral triangles again. But this time, I don't want a hexagon. I want an equilateral triangle. So I'm not going to connect every single point. I'm going to connect every other point. So I'm going to start here with this one and come over, skip this one and come over here this side. And then again, skip the one that's next to it, come to the next one, skip the one that's next to it, and then come back to my original. Those 3 points connect an equilateral triangle that is inscribed in a circle, meaning all 3 points on the vertex are all 3 points of the triangle vertices lie on the circle. So let's go ahead and use the polygon tool so that you can see that triangle very clearly. Okay, so I'm still using that hexagon method, but I'm selecting every other point to find the point that is the points that are going to be equidistant from each other. They are also all equidistant from that center point, because the distances are all the radii of these circles that are all the same size, congruent. All right, slide 6. Construct a regular, all sides of the same length hexagon onto this circle. So guess what? Same thing again. I have this point already here for me. I'll go ahead and click, and intersection back to the center, and intersection back to the center, and new intersection back to the center, and That's all 6 points. I can keep going to make this a beautiful piece of art where I have the complete flower. I don't need the complete flower. I only need all 6 points of those intersections, which currently I have them. So let me go ahead and start adding the segments. This is a hexagon. There we go. To this intersection. So at this time, I'm going to connect all of the intersection points. On the last one, I connected every other to get an equilateral triangle. This time I have to do all of them to get the hexagon that is inscribed into this circle. And if I use the polygon tool, that can show you very clearly where the hexagon is. And there you go. Moving on to slide 7. Construct the angle bisector. Okay, so an angle bisector is very similar to a perpendicular bisector. I need to get a circle onto my vertex of my angle R, and then these 2 points right here are the 2 points that are become important to me. So I'm going to go ahead and label them. So the intersection of the circle labeled. See, do I need the point first? Yeah, I do. So put a point there where circle R intersects the angle, point B. And now basically what we're going to do is a perpendicular bisector of segment AB. I don't even have to draw in AB, but I do need to use my circle tool and click from A to B and from B back to A. Now, if your circles end up going through R, that's going to be a pretty rare instance. That means that you've clicked perfectly and you've created like an equilateral triangle right here. Most of you will not do that. Please remember that you are not clicking back to R. You are clicking from A to B and B back to A. You only do one circle on R. Everything else is from these intersection points. That's why I label them. They're very important. Now actually, let me do a ray. So I'm going to click on R, and my ray needs to go through the intersection of those 2 circles. Okay, the intersection of the 2 circles. So let me just change the color of these 2 circles to remind you that these 2 circles that intersect the angle PRQ are the ones that that you will intersect, that you draw from R through the intersection of those 2. And those 2 are created by using these special intersection points A and B, and then the circle radii have to be the same. So you're going from A to B and then B back to A. Okay, let's move on to the next one. Let's try another one. So I need a a circle on A, and I do not need to go through B or C. Those are just points on the rays of my angle. I just need to do this exactly the same way that I had done it. So I need these important points, these new intersections. So I'm going to go ahead and label them. And then come over here to the other side, label that point. Okay, so D and E. Now I will create 2 new circles that go from D over to E, E back to D. Circle tool, click on D, click on E. Click on E, back to D. And now I'll use the ray tool and draw from A through the intersection of those 2 new circles. And there is my angle bisector. It goes through the exact middle of the angle and divides that into 2. Let's move on. Make the perpendicular bisector of segment AB. So circle from B to A and A back to B. Draw a line or a line segment from the intersection of the 2 circles up to the other side of the line, the intersection of the two circles. And this will give me a perpendicular bisector of segment AB. It bisects segment AB into two equal parts, and this angle created right here is 90 degrees. Moving on. Use perpendicular bisector to find the midpoint of AB. All right, so I thought I changed this. Oh. So I thought I changed the size of this, but apparently I didn't lock it. You are going to have to, if you open this up and AB is really large like that, you are going to have to make it smaller just because the circles, you won't be able to see where they intersect. So change that to a size you can work with and click on circle B, over to circle A back to B, and then we can add in a segment from circle intersection to circle intersection. And now we're going to add a point because we were asked to find the midpoint. So add a point right there and label it. And now we know that C is the midpoint of AB because it lies on the perpendicular bisector. Let's move on. Slide 11. Can you figure out how to make a line that is perpendicular to PQ but actually goes through point C? So yes, we can. If we wanted to go through Z, Z has to be the midpoint, okay? So we need a situation like this, like back here on 10, where Z is going to end up right in the middle. And the way we're going to do that is we're going to create a circle with Z as the middle. And it doesn't really matter where we go. I'm just going to go ahead and go to P. It's there. It doesn't matter. I can make this circle any size. As a matter of fact, I probably should make it a different size so that you don't think P is important. So let me come out here. I'm going to need both intersections. So let me not go too far. Actually, I'll just make it a small one. There we go. Okay. So I'm going to go ahead and click this point and label it. And this point and label it. Okay, so now I have segment AB. Z is the center of segment AB, but what I need is a line that goes through it that's perpendicular. So at this point, I'm just going to use segment AB to do a perpendicular bisector. So I click on the circle tool, click A, go to B, and B back to A. So I just used that first circle to make sure that Z was in the middle of my segment, and now I'm creating the perpendicular. So from circle intersection to circle intersection. Actually, I shouldn't have used the circle, should I? I needed the segment tool. So segment tool, intersection to intersection, goes through Z and is perpendicular to line PQ. Moving on. Copy the angle. All right, to copy an angle, I first need a segment to put my copy on. So that'll work. And then I start with a circle. Actually, I want to label these points, don't I? So let's label this point and label this point. And now let's create a circle on my original, and it can be a circle of any size. And so I do, however, need to be able to measure this. So I'm going to put my important points on there, the intersection of the circle, and label them. All right, so I have my circle and my important points are labeled. Now I will create a segment from B to G or to F, it doesn't matter which. They are both radii. I need to measure the radii so I can use my compass tool. Remember, to use the compass tool, you have to have a segment to click on that will give you your radius. So click More Tools, click Compass, click BG, and move that over to D. Or E if you want the angle to open up a different direction. Doesn't really matter. You're going to get the copy of the angle either way. All right, now I need to measure the opening of the angle. So from G to F, so I can repeat that opening over here on this circle. So I'm going to create a new segment, G to F. Then I go back to my compass tool because my line is so small, you want to make sure that you're clicking on the segment and not the circle, and it looks like I did. So I come over here to this important point. There we go. And this intersection right here will give me the ray that I need, or the segment. Actually, let's go ahead and use ray. So click on D and go through the intersection of those two circles. And let me go ahead and label those points H and I. So HI, the segment HI, if I were to draw that in, would be equal to the segment GF, which is how we know that we have made a copy of this angle. All right, moving on. Copy another angle. So remember, we need to start with a segment. I'm just going to go ahead and keep the orientation the same. And I need now, let me go ahead and label the endpoints. Label and label and get a circle on my original A, circle of any size, label the important intersection points, point, point, select, label, select, label. Okay, so FG are my important points. Now I need a segment from A to F or A to G, doesn't matter. Use my compass tool, click AF so I get a circle of the same size with radius AF. Click it over on D or E, doesn't matter. And let me go ahead and label this important point, the intersection of that circle on segment DE. Then I'll know where to put my next circle center. I need a segment to measure for my next circle from F to G, the opening of that angle. Come over here to my compass tool, click that segment, and come over here to this intersection point. And this ray right here will go through D through the intersection of those two circles. And that will give me the copy of the angle BAC. And I'll label one of those points so I can name this angle. So angle HDE is congruent to angle BAC. Moving on. All right, so I have a couple of pages here where you can practice anything that you want. Let's see, it doesn't have the geometry tool, so I will correct that so that you have the geometry tool to use on these slides. Same thing for 15 and 16. All right, great. Let me know if you have any questions. Happy practicing.